Greetings! Welcome to the lecture of research methodology. In this lecture, I'm going to discuss with you about research plan and proposal writing. I'm Wilson Yong from the Biotechnology Research Institute, University Malaysia Sabah. Formulating a research problem is the first and most important step in the research process. A research problem identifies your destination. It should tell you what you intend to research. The more specific and clearer you are, the better, as everything that follows in the research process, such as study design, measurement procedures, sampling strategy, frame of analysis, and the style of writing of your report, is greatly influenced by the way in which you formulate your research problem. Hence, you should examine it thoroughly, carefully, and critically. The main function of formulating a research problem is to decide what you want to find out about. It is extremely important to evaluate the research problem in the light of the financial resources at your disposal, the time available, and your own and your research team's expertise and knowledge in the field of study. It is equally important to identify any gaps in your knowledge of relevant disciplines, such as statistics required for analysis. Also, ask yourself whether you have sufficient knowledge about computers and software if you plan to use them. The process of formulating a research problem consists of several steps. Step 1. Ask yourself, what is it that really interests me as a professional? As a research student, it is a good idea to think about the field in which you would like to work after graduation. This will help you to find an interesting topic, and one which may be of use to you in the future. For example, if you are a biotechnology student inclined to work in the area of genomics, bioinformatics, or medical biotechnology after graduation, you might take to research in one of these areas. As far as the research journey goes, these are the broad research areas. It is imperative that you identify one of interest to you before undertaking your research journey. At the onset, you will realize that all the broad areas mentioned above, such as genomics, bioinformatics, and medical biotechnology, have many aspects. For example, there are many aspects and issues in the area of medical biotechnology, such as gene therapy, biopharmaceuticals, cellular reprogramming, and etc. In Step 2, you can select any subject area of interest and go through a dissection process. In preparing the list of sub-areas, you should also consult others who have some knowledge of the area and the literature in your subject area. Once you have developed an exhaustive list of the sub-areas from various sources, you proceed to the next step where you select what will become the basis of your inquiry. In Step 3, select issues or sub-areas about which you are passionate. One way to decide what interests you most is to start with the process of elimination. Go through your list and delete all those sub-areas in which you are not very interested. You need to continue this process until you are left with something that is manageable considering the time available to you, your level of expertise, and other resources needed to undertake the study. Once you are confident that you have selected an issue you are passionate about and can manage, you are ready to go to the next step. In Step 4, ask yourself, what is it that I want to find out about in this sub-area? Make a list of whatever questions come to your mind relating to your chosen sub-area, and if you think there are too many to be manageable, go through the process of elimination as you did in Step 3. In Step 5, Both your main objective and your sub-objective need to be formulated, which grow out of your research questions. The main difference between objective and research questions is the way in which they are written. Research questions are obviously that's questions. Objective transform these questions into behavioral aims by using action-oriented words such as to find out, to determine, to ascertain, and to examine. Next, examine your objective to ascertain the feasibility of achieving them through your research endeavor. Consider them in the light of the time, financial and human resources, and technical expertise at your disposal. Finally, go back and give final consideration to whether or not you are sufficiently interested in the study and have adequate resources to undertake it. Ask yourself, am I really enthusiastic about this study? And do I really have enough resources to undertake it? Answer these questions thoughtfully and realistically. If your answer to one of them is no, reassess your objective. One of the important considerations in the formulation of a research problem in quantitative research is the construction of a hypothesis. Hypotheses bring clarity, specificity, and focus to a research problem but are not essential for a study. You can conduct a valid investigation without constructing a single formal hypothesis. On the other hand, within the context of a research study, you can construct as many hypotheses as you consider to be appropriate. The importance of hypotheses lies in their ability to bring direction, specificity, and focus to a research study. They tell a researcher what specific information to collect and thereby provide greater focus. A hypothesis can be defined as a tentative statement about something, the validity of which is usually unknown, or a proposition that is stated in a testable form, and that predicts a particular relationship between two or more variables. A hypothesis is written in such a way that it can be proven or disproven by valid and reliable data. It is in order to obtain this data we perform our study. As mentioned earlier, a hypothesis is important in terms of bringing clarity to the research problem. Specifically, a hypothesis serves the following functions. The formulation of a hypothesis provides a study with focus. It tells you what specific aspects of a research problem to investigate. A hypothesis tells you what data to collect and what not to collect, thereby providing focus to the study. As it provides a focus, the construction of a hypothesis enhances objectivity in a study. A hypothesis may enable you to add to the formulation of theory. It enables you to conclude specifically what is true or what is false. There are a number of considerations to keep in mind when constructing a hypothesis, as they are important for valid verification. The wording of a hypothesis, therefore, must have certain attributes that make it easier for you to ascertain its validity. A hypothesis should be simple, specific, and conceptually clear. There is no place for ambiguity in the construction of a hypothesis, as ambiguity will make the verification of your hypothesis almost impossible. It should be unidimensional, that is, it should test only one relationship at a time. To be able to develop a good hypothesis, you must be familiar with the subject area. The more insight you have into a problem, the easier it is to construct a hypothesis. For example, the average age of the male students in this class is higher than that of the female students. This hypothesis is clear, specific, and easy to test. It tells you what you are attempting to compare: the average age of this class. Which population groups are being compared, female and male students, and what you want to establish: higher average age of the male students. A hypothesis should be capable of verification. Methods and techniques must be available for data collection and analysis. There is no point in formulating a hypothesis if it cannot be subjected to verification because there are no techniques to verify it. However, this does not necessarily mean that you should not formulate a hypothesis for which there are no methods for verification. You might, in the process of doing your research, develop new techniques to verify it. A hypothesis should be related to the existing body of knowledge. It is important that your hypothesis emerges from the existing body of knowledge and that it adds to it, as this is an important function of research. This can only be achieved if the hypothesis has its roots in the existing body of knowledge. A hypothesis should be operationalizable. This means that it can be expressed in terms that can be measured. If it cannot be measured, it cannot be tested, and hence no conclusions can be drawn. To test a hypothesis, you need to go through a process that comprises 3 phases: constructing a hypothesis, gathering appropriate evidence, and analyzing evidence to draw conclusions as to its validity. It is only after analyzing the evidence that you can conclude whether your hypothesis was true or false. When concluding about a hypothesis, conventionally, you specifically make a statement about the correctness or otherwise of a hypothesis in the form of "the hypothesis is true" or "the hypothesis is false." It is therefore imperative that you formulate your hypothesis clearly, precisely, and in a form that is testable. In arriving at a conclusion about the validity of your hypothesis, the way you collect your evidence is of central importance, and it is therefore essential that your study design, sample, data collection methods, data analysis and conclusions, and communication of the conclusions be valid, appropriate, and free from any bias. Having decided what you want to study, you now need to determine how you are going to conduct your study. There are a number of questions that need to be answered before you can proceed with your journey. What procedures will you adopt to obtain answers to research questions? How will you carry out the tasks needed to complete the different components of the research process? What should you do and what should you not do in the process of undertaking the study? Basically, answers to these questions constitute the core of a research design. A research design is a procedural plan that is adopted by the researcher to answer questions validly, objectively, accurately, and economically. Through a research design, you decide for yourself and communicate to others your decisions regarding what study design you propose to use, how you are going to collect information from your respondents, how you are going to select your respondents, how the information you are going to collect is to be analyzed, and how you are going to communicate your findings. In addition, You will need to detail in your research design the rationale and justification for each decision that shapes your answers to the how of the research journey. In presenting your rationale and justification, you need to support them critically from the literature review. You also need to assure yourself and others that the path you have proposed will yield valid and reliable results. The definitions of research design suggest that it has two main functions. The first relates to the identification and development of procedures and logistical arrangements required to undertake a study. And the second emphasizes the importance of quality in these procedures to ensure their validity, objectivity, and accuracy. Hence, through a research design, you conceptualize an operational plan to undertake the various procedures and tasks required to complete your study, and ensure that these procedures are adequate to obtain valid, objective, and accurate answers to the research questions. The research design should detail for you, your supervisor, and other readers all the procedures you plan to use and the tasks you are going to perform to obtain answers to your research questions. One of the most important requirements of a research design is to specify everything clearly so a reader will understand what procedures to follow and how to follow them. In quantitative research, your aim is to determine the relationship between an independent variable and a dependent or outcome variable in a population. Quantitative research designs are either descriptive, in which subjects are usually measured once, or experimental, in which subjects are measured before and after a treatment. A descriptive study establishes only associations between variables. An experiment establishes causality. In a descriptive study, no attempt is made to change behavior or conditions. You measure things as they are. In an experimental study, you take measurements, try some sort of intervention, then take measurements again to see what happened. Descriptive studies are also called observational because you observe the subjects without otherwise intervening. The simplest descriptive study is a case, which reports data on only one subject. Examples are a study of an outstanding athlete or of a dysfunctional institution. Descriptive studies of a few cases are called case series. In cross-sectional studies, variables of interest in a sample of subjects are assayed once and the relationships between them are determined. In prospective or cohort studies, some variables are assayed at the start of a study, for example, dietary habits. Then after a period of time, the outcomes are determined, such as the incidence of heart disease. Another label for this kind of study is longitudinal, although this term also applies to experiments. Case control studies compare cases or subjects with a particular attribute, such as an injury or ability, with controls or subjects without the attribute. Comparison is made of the exposure of something suspected of causing the cases. For example, volume of high-intensity training or number of alcoholic drinks consumed per day. Case control studies are also called retrospective because they focus on conditions in the past that might have caused subjects to become cases rather than controls. Experimental studies are also known as longitudinal or repeated measure studies for obvious reasons. They are also referred to as interventions because you do more than just observe the subjects. In the simplest experiment, a time series, one or more measurements are taken on all subjects before and after a treatment. A special case of the time series is the so-called single subject design, in which measurements are taken repeatedly, for example 10 times, before and after an intervention on one or a few subjects. Time series suffer from a major problem. Any change you see could be due to something other than the treatment. For example, subjects might do better on the second test because of their experience of the first test, or they might change their diet between tests because of a change in weather, and diet could affect their performance of the test. The crossover design is one solution to this problem. Normally, the subjects are given two treatments, one being the real treatment, the other a control or reference treatment. Half the subjects receive the real treatment first, the other half the control first. After a period of time sufficient to allow any treatment effect to wash out, the treatments are crossed over. Any effect of retesting or of anything that happened between the tests can then be subtracted out by an appropriate analysis. If the treatment effect is unlikely to wash out between measurements, a control group has to be used. In these designs, all subjects are measured, but only some of them, the experimental group, then receive the treatment. All subjects are then measured again, and the change in the experimental group is compared with the change in the control group. For an accurate estimate of the relationship between variables, a descriptive study usually needs a sample of hundreds or even thousands of subjects. An experiment, especially a crossover, may need only tens of subjects. The estimate of the relationship is less likely to be biased if you have high participation rate in a sample selected randomly from a population. In experiments, bias is also less likely if your subjects are randomly assigned to treatments, and if subjects and researchers are blind to the identity of the treatments. The design of qualitative research is a general way of thinking about conducting qualitative research. It describes either explicitly or implicitly the purpose of the qualitative research, the role of the researchers, the stages of research, and the method of data analysis. A qualitative research design is probably the most flexible of the various experimental techniques, encompassing a variety of accepted methods and structures. Here, four of the major qualitative research designs, namely ethnography, phenomenology, grounded theory, and case study, are discussed. Ethnographic research is probably the most familiar and applicable type of qualitative method to user experience professionals. In ethnography, you immerse yourself in the target participant's environment to understand the goals, cultures, challenges, motivations, and themes that emerge. Ethnography has its roots in cultural anthropology, where researchers immerse themselves within a culture, often for years. Rather than relying on interviews or surveys, you experience the environment firsthand, and sometimes as a participant observer. When you want to describe an event, activity, or phenomenon, a phenomenological study is an appropriate qualitative method. In a phenomenological study, you use a combination of methods, such as conducting interviews, reading documents, watching videos, or visiting places and events to understand the meaning participants place on whatever is being examined. You rely on the participants' own perspective to provide insight into their motivations. you often conduct a lot of interviews, usually between 5 to 25 for common themes, to build a sufficient dataset to look for emerging themes and to use other participants to validate your findings. Whereas a phenomenological study looks to describe the essence of an activity or event, grounded theory looks to provide an explanation or theory behind the event. You use primarily interviews and existing documents to build a theory based on the data. You go through a series of open and axial coding techniques to identify themes and build the theory. Sample sizes are often also larger, between 20 to 60 with these studies, to better establish a theory. Grounded theory can help inform design decisions by better understanding how a community of users currently use a product or perform tasks. The case study method has evolved over the past few years and developed into a valuable qualitative research method. As the name suggests, it is used for explaining an organization, entity, company, or event. This type of research method is used within a number of areas like education, social sciences, and similar. This method may look difficult to operate. However, it is one of the simplest ways of conducting research, as it involves a deep dive and thorough understanding of the data collection methods and inferring the data. A research plan is a short document which sets out initial thoughts on a research project in a logical and concise manner. It is a concept paper which may be shared in confidence with peers and potential collaborators. Several iterations of a research plan may be necessary before it may be considered as complete. The goal of the research plan is to give others an overview of why you are doing the study and how you are going to conduct the study. Essentially, the research plan is an abbreviated introduction and methodology. In an introduction, the researcher states the aims and objectives of the study, which should explain the purpose of the study and how the study examines the research problem. The significance of the study, which should clarify why this study is important, and the study's research question, which sit at the heart of the what that the study seeks to examine. A well thought out and focused research question leads directly into one or more hypotheses. Testing the hypothesis becomes the justification for the research. Additionally, the research plan addresses the approach of the study, which is either qualitative or quantitative, the research design, and the rationale of the study. The methodology aspect of the research plan describes the population, sampling procedure, as well as the sample and its size. Furthermore, the methodology outlines the instruments and procedures of the study. In both quantitative and qualitative studies, the data analysis plan is presented, as is the types of data to be collected. A research plan is not a formal research proposal, although it may well be the foundation document from which a detailed research proposal may be developed. Having a coherent research plan may help to make the process of writing a research proposal easier and quicker. All research endeavors in both qualitative and quantitative research in every academic and professional field are preceded by a research proposal. It informs your academic supervisor or potential research contract provider about your conceptualization of the total research process that you propose to undertake, so they can examine its validity and appropriateness. In any academic field, your research proposal will go through a number of committees for approval. Unless it is approved by all of them, you will not be able to start your research. Hence, it is important for you to study closely what constitutes a research proposal. Certain requirements for a research proposal may vary from university to university and from discipline to discipline within a university. What is outlined here will satisfy most requirements, but you should be selective regarding what is needed in your situation. A research proposal is an overall plan, scheme, structure, and strategy designed to obtain answers to the research questions or problems that constitute your research project. A research proposal should outline the various tasks you plan to undertake to fulfill your research objective, test hypotheses if any, or obtain answer to your research questions. It should also state your reasons for undertaking the study. Broadly, a research proposal's main function is to detail the operational plan for obtaining answers to your research questions. In doing so, it ensures and reassures the reader of the validity of the methodology for obtaining answers to your research questions accurately and objectively. A research proposal should contain an introduction, including a brief literature review and a theoretical framework that underpins your study, objectives or research questions of your study, hypotheses to be tested if applicable, a study design that you are proposing to adopt, and a setting for your study, research instruments you are planning to use, a sampling design and sample size, methodology and data processing procedures, ethical issues involved and how you propose to deal with them, problems and limitations of the study, a proposed time frame and budget for the project, and expected outcomes and implications based on the extent of research at the time of writing. A research proposal should communicate these contents clearly and specifically in such a way that anyone going through it should be able to undertake all tasks in the same manner as you would have. It should also enable you to return to the proposal for your own guidance in decision making at different stages of the research process, and convince your research supervisor or a reviewer that your proposed methodology is meritorious, valid, appropriate, and workable in terms of obtaining answers to your research questions or objective. Being able to clearly communicate your research proposal, especially to people who are not experts in your field, is an essential skill. It not only helps others understand what you are planning to do, but also helps you to obtain funding, get your research application approved, and even further your career. A successful proposal presentation usually consists of two parts. First is the written proposal with all of the details. This is often a thick document, which is always designed to be read on its own. The second part is the presentation itself, where you get to explain your proposal in person and answer questions. Whether presenting your research or writing about it, here are some tips to help you interest and engage your audience. Make a copy of your proposal document to use as the basis of your presentation. Depending on how much time you have to do the presentation, you will likely want to delete most of the text from this document. Use the executive summary as the framework for your presentation. Articulate a research problem and research questions, and in some cases, a tentative hypothesis. Demonstrate your knowledge of previous research on the topic and your understanding of the gaps. Explain the methods you propose to use and justify why you have chosen these methods. Look at each of the other sections and insert the most important information into your presentation, keeping the information in the same order. It is always good to have a short overview of your research, also known as an elevator pitch, ready for when anyone asks you what you do. This should be 1 minute or less and can also be included at the start of a presentation to summarize your work before going into more depth. Use this to explain why your research is exciting, what about it made you choose to research this area, and how is your research relevant to the outside world. As much as people may complain about PowerPoint, it is still the medium of choice for most presentations. There are lots of templates available to use, but you would do best to keep your presentation very clean and simple. Limit the amount of information on each slide to only the most important bullet points, and use your presenter's notes to discuss what is on each slide. If you are using a whiteboard, consider writing yourself notes based on the proposal you are presenting, rather than writing a speech which you would have to read line for line. Regardless of what you use, practice the presentation a few times before going into the presentation meeting. Where possible, use illustrations to help explain the science. Use images and color for impact, which will help you keep the audience's attention. Try to avoid using complex diagrams, graphs, or tables, as this could cause the audience to lose interest. Avoid using animation, which can be tedious and distracting. Use large enough letters so people can read them. Limit your slides to several bullet points each. Use plenty of blank space. Whenever possible, find out who is going to be attending your presentation meeting. Always bring a few extra copies of your written proposal so that everyone will have one. In most cases, your audience will consist of people with varying levels of knowledge about your topic. Your presentation should be detailed enough to satisfy the experts, without going over the heads of those who aren't experts. Keep it simple and invite your audience to refer to specific pages in the written document for additional information. It is important to understand how much science your audience is likely to know, so you can tailor your language and ensure they will be able to get the most out of your presentation, fully understanding the content. To help them understand any concepts and ideas that are more complex or harder to explain, relate the points to something your audience knows. Explain why you are doing your research and the impact it could have in the future. If applicable, name an important issue your research addresses, such as climate change, industrial revolution, and etc., but avoid misinterpretation. Try to make your presentation as captivating as possible. Show your passion for your research and why it motivates you. Exclude details that may not be interesting to avoid losing the attention of your audience. Simplify your main message if that makes it easier to understand. Whether writing about your research or presenting it in person, by following these steps, you will effectively engage your audience and help those who aren't experts in your field understand the importance and relevance of your research. When they fully understand what you are researching and why, people are more likely to be interested and remember what you do. With that, I would like to end this presentation. I hope you enjoyed the topic. Thank you so much for joining me and participating in this lecture. Thank you.